Hi, this is Jessie Keaveney, and we're working with the time value of money. We're doing chapter 4, part 3. We're starting on problem number 20. It asks, you are valuing an investment that will pay you $12,000 the first year, $14,000 the second year, $17,000 the third year, $19,000 the fourth year, $23,000 the fifth year, and $29,000 the sixth year. All payments are at the end of each year. What is the value of the investment to you now if an appropriate annual discount rate is 11%? So the first thing we want to do is we want to go to a problem that has the cash flows written out where you can have different cash flows. So we're going to copy that, come back over here, right click, paste, and we need 6 years. So we're just going to copy this out so that we can have 6 years. And then we want to change our formula. You see when you go into the formula, it highlights it. It's going through H. So we want the formula to go through I. Okay. And then the interest rate is 11%. So we're going to change that here. And it says $12,000 the first year, $14,000 the second year, $17,000, $19,000, $23,000, and $29,000. And so that gives us a net present value, which is the same thing as the present value in this case, of $76,273.63. Okay, the next problem. You are thinking of an investment that will pay $27,000 per year for the first 10 years, $35,000 per year for the next 10 years, and $48,000 per annum the following 10 years. All payments are at the end of each year. If the appropriate return on a similar investment is 9%, what is the value of the investment to you today? So we're just going to copy this one, paste it down, and it looks like 10, we've got 30 years we've got to extend this. So if we just do this, do 1 plus that one, and then just take that, copy those cells and extend it out. That's to 27, oops, undo. We're going to copy that out to 30. Okay. All right, so the interest rate is 9%. The first 10 years is $27,000. So we're going to copy that through year 10. The next 10 years is $35,000. So copy that through year 20. And then the next 10 years is $48,000. So extend that out to 30. And then we want to make sure that the formula goes all the way out to AG is where the end of that formula is. So we're just going to change that from I to AG so you can see that it's highlighted all the way across. Just hit enter. So that gives us a net present value of $323,123.04. Okay, the next problem. John and Peggy recently bought a house. They financed the house with a $125,000 30-year mortgage with a nominal interest rate of 7%. Mortgage payments are made at the end of each month. What total dollar amount of their mortgage payments during the first 3 years will go towards repayment of the principal? Okay, we've got some information here, but in order to do an amortization schedule, we need to know what the payment is. So we're going to go find something that has a payment. Like in this case, it has a payment and an amortization schedule. So we're going to copy that and paste that here. So they've financed the house, so it's $125,000. It's a 30-year mortgage, but there's payments every month, so it's 30 years times 12, 360 months, and then the nominal interest rate is 7%. So we're going to take 7% divided by 12 because the payments are monthly. So that tells us that the payment is $831.63. Okay, so you can look at this amortization schedule here that started. So this is automatically looking at the beginning of the mortgage is $125,000. It's giving me the payment of $831.63. It's linking to there. However, the interest is not calculating correctly, and that is it's not linking over here because it's looking, because when I pasted it, it's going to whenever you see a dollar sign in front of the cell reference or in front of the numbers of the columns in the row, it means that it's set. It's set so that it'll always, when you copy that cell down, it'll always be referencing D70. So the actual reference that we want it to be is actually cell C33, because that's the interest rate. So you're taking the beginning amount times the interest rate. So we want to change that. Just keep the dollar sign. It's just going to be $C and then $33. Okay, and then we can copy that down. So you can see here, I'm just going to fix the formatting because that's going to bug me. That it's still referencing cell C33 even on row E45. Okay, and then the repayment of the principal is just taking the difference between the total payment and the interest, and then the ending balance is taking the total of the beginning amount less the repayment of the principal. So then the new beginning amount on year 2 starts with the ending balance from year 1. Okay, so what we can do here is we can extend this down, this amortization schedule, because it's looking for the first, at the end of the first 3 years. So 3 years times 12, we're gonna need 36 months of what that total and the repayment of principal is. Okay, so I am going to copy this row here and then just change this formula so that when we copy it down, it'll automatically tell me how many months or how many years. It's actually not years, it's months. Just change that. And copy this down. Copy that down one more. Okay, then we can take the total of that column. So that gives us a total of $4,091.30, and that is the principal amount paid in the most recent 3 years. Okay, the next question. You are valuing an investment that will pay you $26,000 per year for the first 9 years, $34,000 per year for the next 11 years, and $47,000 per annum for the following 14 years. All payments are made at the end of each year. If an alternative investment with a similar risk pays 9% return compounding monthly, what is the value of the stream of cash flows today? So we can go ahead and take this template that we started up here for net present value of cash flows, copy that down here. Okay. And we want this to go out, so it's got 9 years, it's got 11 years, and it's got 14 years. So we want 34 years. So let's extend that out a little bit more and fix the formula. And that's going to column AK. And you know what? I paste special as values. You don't want to paste special as values. You want the formulas in there. So I'm going to repaste that to here. Okay. I'm just going to make sure the formatting's the same. Okay, this I want to go out to AK. So I just changed the formula to go all the way out to AK so you can see it's highlighted. Okay, so $26,000 per year for the first 9 years. Okay. $34,000 per year for the next 11 years. Okay, and then $47,000 per year for the next 14 years. Okay, now it's saying 9% return compounding monthly. Okay, so we want to find where we have that effective rate. There it is. So copy that, go back over here and paste. So it's 9% compounding monthly is 9.38. So just link that down here. So then that gives us a net present value of the stream of cash flows of $314,518.20. Okay, next problem. You have just won the Georgia lottery with a jackpot of $40 million. Your winnings will be paid to you in 26 equal annual installments with the first payment made immediately. If you feel the appropriate annual discount rate is 8%, what is the present value of the stream of payments you will receive? Okay. So we want to get, let's see, go to the other file. Want to look for present value. Paste that here. Okay, your jackpot is $40 million. Your winnings will be paid to you in 26 equal annual installments. So we're going to look at the 40 million divided by 26. That's going to be your payment. The annual discount rate is 8%. And 26, and the thing here is it's an annuity due, so we need to put a 1 at the end. I'm just gonna add a minus sign just so that it's not gonna show up as negative. And then that gives us a present value of $17,961,194.14. So don't forget that the first payment is made immediately, so that means that you've got to put the 1 as the type because it is an annuity due. Okay, you have just won the Georgia lottery again with a jackpot of $11 million. Your winnings will be paid to you in 26 equal annual installments with the first payment made immediately. So we have another annuity due. If you had the money now, you would invest it in an account with an interest rate of 9% compounding monthly. What is the present value of the stream of payments you will receive? Okay. I'm going to, let's go ahead and copy, because we need the 9% compounding monthly. So it's already got the 9% and the 12, so that's our interest rate. And let's copy that part down. 26 equal installments. We're going to change that to link up here. That's the effective rate. And then the payments are $11 million divided by 26. Okay, so that gives us $4,453,793.24. Okay, next problem. You are planning for retirement in 34 years from now. You plan to invest $4,200 per year for the first 7 years, $6,900 per year for the next 11 years, and $14,500 per annum for the following 16 years. Assume all cash flows occur at the end of each year in a retirement account. If you believe that you will earn an effective annual rate of 9.7%, what will your retirement investment be worth in 34 years from now? Okay, so we first need to understand what our present value is before we can figure out our future value. So we're going to copy this template again down here, because we have uneven cash flows. We have to do it this way. Effective annual rate of 9.7%. Okay, and you've got 7 years, you've got 11 years, and you've got 16 years. We have 34 years, and that's the amount that we have here, so we don't have to change the formula on that. And we're going to put $4,200 per year for the first 7 years. And then $6,900 per year for the next 11 years. And then $14,500 per year for the remainder, which is 16 years. Okay, so that gives us a net present value of $66,239.98. But that's our present value. We want to know how much our retirement investment will be worth 34 years from now. Okay, so I need to get a future value. So let's see if we can get a future value. Paste that here. Okay, we have 34 years, 9.7%, and then we have a present value, and that gives us our future value of $1,542,217.26. Okay, last one is a big one. You plan to retire 33 years from now. You expect that you will live 27 years after retiring. You want to have enough money upon reaching retirement age to withdraw $180,000 from the account at the beginning of each year you expect to live, and yet still have $2,500,000 left in the account at the time of your expected death, which is 60 years from now. You plan to fund the retirement fund by making equal annual deposits at the end of the year for the next 33 years. You expect to earn 12% per year on your deposits. However, you expect to earn only 6% per year on your investment after you retire, since you will choose to place the money in less risky investments. What equal annual deposits must you make each year to reach your retirement goal? Phew, that's a lot. So, in this word problem, you've got to kind of break it down into like a timeline. You've got to think, you've got 33 years that you're calculating, which is what that problem is stating. What equal annual deposits must you make each year to reach your retirement goal? So you've got these payments as you're working to reach retirement. Then once you reach retirement, you've got another 27 years to go after retiring. Okay, so what we know, so you've got to break it, there's two different parts to this. Well, what we know is that at the very, very end, when you die, you want $2,500,000 left in the account. Okay, and you know that you're going to withdraw $180,000 each year, and you know the end. So knowing that you know the future value at the very end of your timeline, you want to get to the present value at the time of retirement. Okay, so we want a present value. So we're going to put that there. We're going to change this because this is not an annuity due. Okay, so N is 27 years of making withdrawals. You know that the interest rate, it says you expect to earn only 6% per year on your investment after you retire. Okay, your payment is $180,000 a year, and your future value, you know, at the very end, is going to be $2.5 million. Let's see. Oh, it is an annuity due. It says you want to have enough money upon reaching retirement age to withdraw $180,000 from the account at the beginning of each year. So that needs to be, I need to go back, and that's a comma 1. Okay, so that gives us a present value of $38,989.79. Okay, now that we know the present value at the time of retirement, that becomes our future value when you're looking at the other part of your timeline where you're making annual deposits in order to meet your retirement goal. Okay, so we're going to copy the future value section down here. Your present value is here. Oh. I'm sorry. Get rid of that. The question is, what equal annual deposits must you make? So what you're really trying to find is your payment. I apologize. So up here, I'm going to copy that section. Go down here and hit payment. So your present value, your future value is going to be this $3 million. Your N, it says you plan to retire 33 years from now. So it's 33 years that you're making those deposits, and you're getting 12% per year. So your payments are $8,874.79. Okay, and that's it for chapter 4. Thank you very much.